Okay, on this video, we're doing the heat curve calculations. The most important thing you need from this worksheet, the heat of vaporization value. So vaporization or condensation, vaporization, we're vaporizing. We're going from a liquid to a gas. And then condensation would be the opposite. We're going from a gas to a liquid. And then heat of fusion and heat of solidification. So now we're taking ice to water, or water and freezing it to ice. And so these are the two values. What you're going to have to do is figure out which value do you need for each problem. So for number one, calculate the energy needed to vaporize. So for 1A, B, and C, we're going to use 2,330 joules per gram. So for number one, we take our 25 grams of water and we say 2,330 joules per 1 gram. We multiply that out. You should get 58,250 joules. And if we convert that to kilojoules, it would be 58.25 kilojoules. And it says to draw a box around your answers. So that's it for that one. The next one, 6.75 kilograms of water. So the first thing we have to do is change kilograms to grams. We do that by moving our decimal 3 places to the left. So we end up with 6,750 grams. We use our same value here, 2,330 joules per 1 gram. We multiply that out and we end up getting, what is this, 15,727,500 joules. So 15,727,500 joules, or we would say kilojoules, 15727.5 kilojoules. And then for the third one, 5.88 moles of water. So the first thing we have to do is convert moles to grams. So going back all the way to chapter 3, we look up the molar mass from the periodic table for water, and it is 18.02 grams. So then that gives me 105.96 grams of water. So now I can plug in my 2,330 joules per gram, and that would give me 246,881.2 joules. And then if I wanted to put this in kilojoules, I would end up having 246.8812 kilojoules. So then that would be my answer for C. All right, so now, number 2, you're doing the exact same thing. This time they've given you kilojoules, and you've got to change it to grams. So instead of multiplying by 2330, first you're going to have to change kilojoules to joules by moving your decimal 3 places to the right, and then dividing by 2,330 instead of multiplying. And then on part 3, calculate the energy needed to melt. So now we're going to have to use this heat of fusion value, this 335 joules per gram. So we pretty much do it the same way. We're going to take our 33 grams of water, and we're going to multiply it by 335 joules per gram. Or this would be 11.055 kilojoules. and then 7.75 kilograms of water. So we have to change that to grams by moving our decimal 3 times to the right. So 7750 grams. We're going to multiply that by 335 joules. Here's our answer in joules and kilojoules. And then again, they give us one in moles of water. So the first thing we have to do is take that moles and convert it to grams. We know from the periodic table and our molar mass that there are 18.02 grams of water in every mole. So this gives us 76.585 grams. And then to put that in kilograms, we end up doing 25.655975 kilojoules. All right. And then number 4, they've given it to you in kilojoules. Move your decimal 3 places to the right. Now divide it by 335 joules per gram. On part 5, they've mixed them together. So you have to decide by the sentence that they've given you, is it vaporizing and condensing, or is it fusing and solidifying? On number 6, you're going to get your answer in joules. For the first part, you're going to take your 20-gram sample and you're going to multiply it by the correct delta H value to get joules. Then you're going to use that Q equals MC delta T. M is your 20 grams. C for water is 4.184. Temperature goes from 20 to 0, so 20 minus 0 is 20. You'll calculate your Q, and then you'll add your 2 answers together, and that will give you your total value on number 6. If you have more questions about number 6, just come see me and I'll help you with it. And that's it for this worksheet.